Tonight, the moon is just gone. Not hidden, not eclipsed. Gone. Look up, and that pale disk that has hung there every clear night of your entire life simply is not there anymore. Probably nothing. That's the honest first reaction. It's just a rock, a light in the sky, something for love songs and tide charts. Hold that thought, because you're about to find out exactly how wrong it is. Most of us file the moon under poetry, not physics. Something to howl at, to write songs about, to glance at on a walk home, not something with a job to do. But this rock has been quietly load-bearing for the entire span of life on Earth, wired into your coastline, your nights, the stability of the ground under your feet. Think about a tightrope walker's pole. Nobody watches the pole. It isn't the performance, but it's the reason the walker doesn't fall, making tiny corrections nobody notices, precisely because they keep working. The moon has been that pole for this entire planet, for billions of years. And tonight, we're pulling it away to see everything it was quietly holding up. So here's the first, most immediate answer, and it's a real one. Tides don't vanish. The sun still tugs at Earth's oceans. But within hours, the twice-daily rise and fall that has shaped every coastline on the planet collapses to a fraction of what it was. That's a satisfying, checkable fact. You could watch it happen from a beach chair by lunchtime. But it's also just the first domino. It's the fast, visible layer sitting on top of something much bigger, because if the moon has been quietly steering something as vast as the ocean this whole time, the real question is what else it's been holding in place. And for how long has it been doing that without anyone noticing? To answer that, picture Earth the way a physicist would. A spinning top, tilted slightly, turning in the dark. Left alone, spinning tops don't stay steady forever. They wobble, they drift. Eventually, they topple. Now picture a hand resting lightly near that top, not touching it, just exerting a constant, gentle pull from a short distance away. That's the moon. Its gravity does two simple things. It pulls on Earth's water, which is the tides, and it exerts a steady, patient tug on Earth's tilt and its spin, the same way that hand keeps the top from wandering off balance. You might reasonably ask why a rock 384,000 kilometers away would matter at all, given how far that is and how small the moon looks from here. The answer is that mass and distance and a pull that never once stops add up, especially when you let that pull compound for 4.5 billion years without a single pause. A small, steady force, given enough time, becomes an enormous one. The difference between a light touch on a top for 1 second and a hand that has never once let go for the entire lifetime of the top. That is the moon's real relationship to this planet, and it's the frame for everything that follows. So start with the fastest, most visible piece of that arrangement, the one you'd notice by morning. What actually happens to a coastline when its twice-daily rhythm collapses? First, the numbers behind it. The moon accounts for roughly 2/3 of Earth's total tidal pool, the sun for the rest, despite being unimaginably more massive, simply because it's so much farther away. Take the moon away, and you're left with solar tides alone, at something like 1/3 of today's range, and without the familiar back and forth of spring and neap tides that estuaries and shorelines have always run on. That already sounds significant. But it's not just smaller waves lapping at a smaller shore. It's tidal pools that stop refilling on schedule, stranding the anemones and crabs and small fish that depend on that twice-daily refresh just to survive between one high tide and the next. It's estuaries that no longer flush and refill twice a day, carrying nutrients in and waste out on a rhythm as reliable as a heartbeat. A rhythm entire food webs are built around without ever needing to think about it. It's salt marshes that depend on that daily flood reaching just far enough to feed the plants and animals living right at the average waterline. No further and no less. The machinery keeps running, technically. There's still water, still motion, still something that looks from a distance like a tide. But the precision is gone. And precision was always the whole point of the arrangement. And precision is exactly what a staggering number of species have built their entire lives around, down to the day. Red knots, a small shorebird, fly over 9,000 miles from the southern tip of South America, timed with almost absurd precision to land at Delaware Bay exactly when horseshoe crabs are spawning on the high spring tides. Miss that window by even a few days, and there's no food waiting. No second chance that season, no do-over before the next migration comes around. Coral on reefs half a world away spawn in a single synchronized mass event, cued in part by moonlight together with the tide, so that eggs and sperm released by millions of individuals meet in the water at the same moment instead of drifting apart uselessly into open ocean. These aren't backup systems built with slack in them. They are the only system tuned to a clock that has never once skipped a beat in the whole of evolutionary history. So the coastline doesn't just get quieter without the moon. It loses the clock it was built around. Every low tide and high tide it used to set its watch by, gone, replaced by a flatter, vaguer rhythm that nothing alive today was ever designed to read. Look up again. That's where the moon should be, and it isn't. The tides were the fast damage, the one you could point to by sunrise. But the real cost starts after dark, in a place you can't check from a beach chair. Here's the baseline fact people rarely think about. A full moon is dim by daylight standards, somewhere around 1/10 of a lux, but compared to a moonless, starlit night, which sits at under 100th of that, it's the difference between total blackout and just enough light to make out the shape of the land, a path, a predator, a rippling patch of water. Moonlight is the gap between the darkest night you've ever experienced and the brightest one. Take the moon away permanently, and every single night converges on that darkest end. Not occasionally, on the cloudy or new moon nights we already get sometimes. Always, forever, starting tonight and never letting up again. That's not a cosmetic change. A slightly moodier sky for a slightly moodier photograph. Moonlight is a functioning light source, and a staggering number of nocturnal animals are built around using it as one, whether they know it or not. Owls and other night hunters rely on that faint illumination to spot the flick of movement across open ground, the difference between a successful hunt and an empty stomach at dawn. Migrating birds, the Eurasian skylark among them, fly at night in far greater numbers when the moon is fuller and brighter, using that light to navigate long distances safely through darkness that would otherwise swallow every landmark below. Take the light away, and you haven't just dimmed their world. You've deleted the tool they use to move through it at all. And these aren't habits any species can simply relearn on the fly, the way you might feel your way along a dark hallway you already know. They're systems tuned over millions of years, predator success rates calibrated to exactly how visible prey is on a moonlit night. Migration timing built around lunar cycles that have repeated with total reliability since long before there were eyes to notice them at all. There's no fallback behavior sitting in reserve for a permanently moonless world, because a permanently moonless world never existed for these species to prepare for. It was never on the table, not once in the entire history of life on this planet. The systems don't gently adapt, they just fail, all at once, everywhere the moon used to reach. On the very first night, it doesn't. So it isn't that nights get a bit darker without the moon. Darkness itself becomes total and permanent, and for a huge share of the animals operating after sunset, that's not an inconvenience to work around. It's the floor falling out from under a way of life that never had a plan B because it never once needed one. Look at that empty patch of sky one more time. The dark you're picturing now wasn't even the deepest problem. Underneath the missing tides and the missing light is something quieter, never visible on any single night. What happens to Earth's tilt, the thing that gives us seasons, once its steadying hand is gone? For nearly the entire history of this planet, the moon has held Earth's axial tilt locked into a narrow, stable band, cycling gently between about 22 and 24.5 degrees over tens of thousands of years. That narrow range is the reason the seasons you've always known, predictable, repeating, survivable, the kind you can plant a crop or migrate a herd around, have stayed predictable for the entire span of human history and long before it. It's the steadying hand on the spinning top, and it has been resting there since almost the beginning of the planet itself. 4.5 billion years of one continuous, gentle correction. Take that hand away, and the tilt doesn't just stay put out of habit, the way a top might spin a while longer on its own momentum. Left to its own devices, Earth's axis would begin to wander, slowly, almost imperceptibly at first. The kind of drift you'd need centuries to even notice from the ground. But wandering compounds, the same way the moon's small, steady pull compounded into something enormous. Over tens of thousands of years, without the moon's steady pull, that drift could swing wildly, potentially anywhere from nearly upright to tipped almost onto its side. Compare that to Mars, a planet without a large stabilizing moon of its own, whose axial tilt has swung dramatically over its history, by some estimates from 10 degrees to 60. That's not a planet with seasons anymore. That's a planet playing climate roulette with itself, over and over, for the rest of its history, with nothing there to call it back to center. And there's a second, quieter mechanism unraveling at exactly the same time, one that has nothing to do with tilt and everything to do with the clock itself. The moon has been gently breaking Earth's spin for its entire existence, which is the reason our days have been slowly, almost imperceptibly lengthening for billions of years, stretching by fractions of a second every century, so gradually that no living thing has ever felt it happen. Remove the moon, and that break releases. The day stops stretching. It simply freezes, locked forever at whatever length it happened to be the moment the moon disappeared, neither shortening nor lengthening ever again, an accident of timing carried for the rest of the planet's history. So the moon was never just lighting the night or nudging the tide twice a day. It's been the reason this planet's seasons and its days have stayed steady long enough for anything at all. A coral reef, a migrating bird, you, to evolve while quietly betting everything on that steadiness holding. So go back to where we started. What if, tonight, the moon just vanished? Now you can actually see what that sentence costs, in full, as one connected chain rather than a list of separate facts. Within hours, the tides you'd normally set your watch by collapse to a fraction of themselves, and every ecosystem timed to that rhythm loses the cue it depends on. By nightfall, every night from now on is as dark as the darkest night this planet currently gets, permanently, and a huge share of nocturnal life loses the only light it has ever hunted or navigated or migrated by. And over the tens of thousands of years after that, the deeper structure comes loose, the part that was never visible on any single night. The tilt that gives us stable seasons begins to wander toward chaos, And the day length that's been quietly stretching for billions of years simply stops, frozen in place forever, at whatever number it happened to land on. 15 minutes ago, this would have sounded like nothing. A rock, gone, so what? Now you can see it for what it actually is. A single connected chain reaction, running from a beach at low tide to a bird flying blind through a black sky, to the very axis the entire planet spins on. The moon was never decoration hanging up there for the view. It was the counterweight the whole arrangement was quietly built on top of, the hand that never once let go of the top. And here's the part worth sitting with. We very nearly never had one. Around 4.5 billion years ago, in Earth's first chaotic tens of millions of years, a Mars-sized world some scientists call Theia, a body that new evidence suggests may have formed even closer to the Sun than Earth did, slammed into the young planet in a collision violent enough to reshape both worlds. Out of that wreckage, out of debris flung into orbit by pure catastrophic accident, the moon slowly gathered itself together. It didn't have to happen. A slightly different angle, a slightly different timing, and that same collision produces no moon at all. Just two shattered rocks and an empty night sky, forever, with nothing overhead to keep any of this steady. Every tide pool, every night-hunting owl, every stable season you have ever lived through exists because of that one chance encounter, billions of years before anything alive was here to benefit from it, or even to know to be grateful for it. Nothing about it was owed to us. And yet, here it still is, close enough to see, steady enough to trust, holding on quietly overhead. So look up again, one last time. The moon is still there tonight, hanging in the dark exactly where it's always been, doing the same patient, invisible work it's done for 4.5 billion years. It's a small companion, orbiting a small blue dot, and between the two of them, they've been keeping something very fragile, very steady for a very long time. We'll keep looking closely at things like this, the quiet, overlooked machinery holding the world together in plain sight. For now, it's enough to know the sky looks a little different than it did 15 minutes ago,